So the lookup algorithm that a router uses depends on the protocol that it's using to forward packets. And the lookup mechanism might be implemented with a variety of different algorithms or techniques. For example, MPLS, Ethernet, and ATM use an exact match lookup. Exact matches can be implemented as a direct lookup, an associative lookup, hashing, or via a binary tree. IPv4 and IPv6, on the other hand, are implemented with what's called longest prefix match. We've already looked at longest prefix match a little bit in some lessons, and in this lesson we'll look at it in a bit more detail as well as how it's implemented. It might be implemented as a radix trie, a compressed trie, which is something that we will look at in this lesson, and it can also be implemented as a binary search on prefix intervals. Ethernet-based forwarding is based on exact match of a layer 2 address, which is usually 48 bits long. The address is global, not just local to the link, and the range or size of the address is not negotiable. Now 2 to the 48th is far bigger than 2 to the 12th, therefore it's not possible to hold all the addresses in the table and use direct lookup. The advantages of exact matches in Ethernet switches is that exact match is simple and the expected lookup time is small, or O of 1. But the disadvantages include inefficient use of memory. This potentially results in non-deterministic lookup time if a lookup might require multiple memory accesses. Let's now take a closer look at longest prefix match.